All right, so we're just going to go over this 3.5. It's population growth and resources. It's a lot of the same stuff we've kind of been talking about and what was in the video. So density dependent factors are anything that's going to depend on density of a population that can then change population growth rates. So that means that it would be something that like disease will spread quicker when you have higher density because people are all in one place. We know this very well now because since March we've been hearing about how to prevent COVID, and one of those things is not having big gatherings, especially in indoor locations. So these are things that depend on density. Physiological stress can be density dependent. That just means when you have more organisms together, there's going to be some stress because they can't get enough resources, food, shelter, stuff like that. Predation. So it's easier for a predator to eat prey if there's lots of prey because it can find them easier. Density independent factors are things that don't depend on density, so those are things that will affect everyone equally. So things like forest fire, drought, habitat destruction, glacial movements, things like that. The way I like to think of it is a density dependent factor would be if I had pizza in my classroom at lunchtime and we were going to have a club meeting. Say I had 2 pizzas and I had like 16 slices, but there were 20 people at the meeting. Some of the people would have to leave the meeting to go get lunch at the lounge or something like that, and then come back. That's a density dependent factor. The amount of pizza slices depends on how many people there are that are going to eat it, what's going to happen. If the club meeting only had 8 people and I had 16 slices of pizza, we're good because we have plenty of pizza for everyone who's there. A density independent factor would be if the building caught on fire. It doesn't matter how many people I have in the room, we're all going to leave, right? Because the building's on fire. So density independent affects everyone equally, regardless of how many individuals there are. Density dependent affects everyone based on the number of individuals there are. And then resource availability, when it shrinks, this can lead to population changes in different ways. So we talked about like the capacity of individuals to have like offspring. So we talked up here about our biotic potential way up. Yeah, right here. So it was in, I think, 3.2. Yes, 3.2. We talked about biotic potential. Another way to talk about that is to call it fecundity. So fecundity is basically how many offspring you're going to have. So same thing as biotic potential, just different vocab. So if organisms aren't very healthy because there's not sufficient resources, they will tend to have fewer offspring, or not have any offspring, or have offspring less often. So in a rabbit population where there's plenty of things for the rabbit to eat, it's going to have babies frequently and it's going to have large litters. If you have a rabbit that is very, very skinny because it can't get enough food, it may not be healthy enough to have a baby at all, or it might have a litter of only 1 or 2 individuals. I found a mom dog when I was a grad student who had had her pup, but she had been like abandoned, and she was so skinny, and she had only had 1 pup in that litter. If she would have been like well taken care of and not abandoned somewhere in the woods or on the side of the road, she probably would have had a bigger litter. This happened a lot in Auburn. It's a college town, so kids would get a dog and then their parents would say you can't take the dog home for summer, and they just like dump it. And this poor girl had the pup and wasn't taken care of, and so we helped her out. My friends have her puppy right now, so I get to see her little puppy grow up. But yeah, so that's an example of that lower fecundity. She was starving, and so even though she could get pregnant because she had enough resources for that, she only had a litter of 1 puppy because she had that lower fecundity because of that resource availability. If resource availability shrinks enough, you can get mortality. So of course that's death of organisms. Some of the animals can starve to death. This is what happens with deer in some areas. If you don't have a lot of hunting, we've killed off most of the natural predators of deer. So deer will either get hunted by humans or starve to death in most of the US. Once the population though is back to or below the carrying capacity, then you can have some stabilization. And so then it will be kind of like a normal level again. So that's all we're going to talk about today. In 3.6, it's going to move on to human population stuff. So that's where we're going to start next week. This week, we're going to be dealing with all maths and graph and kind of reinforcing what we've learned so far.